So let us discuss this very important concept of this subject topology, that is open set. So let us discuss the definition of open set. Okay, I will write here, let XD be a metric space. Okay, so we have a metric space here, XD be a metric space. So what will I do? I will draw the diagram simultaneously, so it will help to understand. Okay, so suppose this is a matrix space XD. This is a matrix space XD. A subset U of X is said to be open. See what we have. So suppose this is a set. Okay, this is set U. This is set U, which is a subset of X. When we say U is open, if for every X belongs to U, if you take any point X belongs to U, there exists R greater than 0, R means radius, such that BXR subset of U. Okay, so that means if you select any arbitrary point X, then you should able to draw an open ball around it which will lie entirely inside set U. Then you can declare U is open. Getting the point? Okay, I will explain one more time. So that means suppose this is set U, this is set U. If you have this point X, then you can draw open ball around it which will lie inside U. If you have X here or if you have Y here, you can draw a large ball, so which will lie entirely inside U. But if you have a X here, if you have X very close to boundary, what will happen? No problem. We will take a very small radius and we will draw a ball around it. So definitely, is it visible to you? Yeah, I'm drawing a ball with very small radius which is lying entirely inside set U, no problem. Okay, then also you can declare it as an open ball. But if this set U contains some boundary point P, then what will happen? If I draw ball of any radius, definitely some part of ball will go outside the U. So that's why in that case you can say U is not an open set. That means what can we say? If any point lies on a boundary, if that is also member of U, so if you draw any ball around it, it will go outside. Okay, otherwise it will be an open set. So I will repeat the definition. What we want here, it is said to be open for every X belongs to U. For each point of U, it is possible to draw open ball around it which can lie entirely inside U. Then only we can declare U is an open set. Okay, I will explain one more time. Just a minute. I will give one real life example and then we will discuss. Let us take example of this room where I'm recording. Okay, recording this video. So the structure of room is like this. Okay, so that room is like this. Okay, so here is one door, there is one door. How shall I show? Dotted line. There is one door and this is a room where I am recording. Okay, so if I stand here, okay, actually I am recording here. I am here. Okay, I am here. So I am going to check whether it is possible to draw open ball around me which can lie entirely inside this room. So suppose I am here at this point. So there is some distance from a boundary. So I can draw ball around it which can lie entirely inside U. So if I am here, then also it is possible to draw ball around it which can lie entirely inside room. You are getting the point? If I am here, then there is no issue. You can draw a large ball around me which can lie entirely inside room. If I am here, no issue. I can draw a small ball, no problem. But if I at the door, okay, or if I at the boundary, so then if I draw any ball around me, then definitely some part of ball will go outside the room. That means if I am on a boundary, so then we can declare it won't be an open set. Otherwise, if you discuss all these points, then you can say that is a member of U, or any ball around it member of proper subset of U. So that's why we can declare it will be an open set. So let us discuss one example of real line. Okay, so since we are already familiar with real line, just a minute, just a minute. See, I am considering let X is equal to R, set of real numbers, and D, this is a usual metric. Okay, D is a usual matrix. So if I consider set A is equal to 2 comma 3, 2 comma 3, huh? So this 0 1 2 3 4. See, open interval, are you familiar with this concept? Open interval, that means it does not contain its boundary points. So see, 2 3 will be like this, 2 3 will be like this. Tell me, 2 is a member of this set? No. 3 is a member of this set? No. Since it is an open interval, it does not contain its boundary. So if you consider any point P inside set, then definitely you can draw open ball around it. Actually, it will not look like a circle since it is a real line. So its open ball will be like an interval. So we can have an interval which can proper subset of 2 comma 3. So therefore we can declare it is an open set. You are getting my point? But if I consider a set like this, B is equal to close interval 3 4, 0 1 2 3 4. So 3 and 4 are included here since this is a closed set. And if I consider 4 here, and if I try to draw any open ball around it, so some part of ball will go outside the set 3 comma 4. So therefore it will not be an open set. Okay, I can understand for this point we can draw. But what is the condition for every point? That is very important. For every point it should be proper subset of U. But see here, in this case it is possible, but for 4 it is not possible. So if I get any point, okay, for that it is not possible, then we can declare it is not an open set. So what is our conclusion? This is an open set, but this is not an open set. If you want, you can make screenshot of it. Please make a screenshot of it, and after that we will stop. Thank you. Bye bye.